Rama Rana. I have here Shivani Mektre along with me, and on the cameras we have Shakti Suresh, we are a team. And today we are going to demonstrate that how on increasing the shear force there's an increase in the viscosity of this mixture that we are going to take. So there are three types of substances actually. The first one is the other substances whose viscosity does not change with increase in shear force. We can take an example of all sorts of liquids that are present. The second ones are called thixotropic. These are the substances whose viscosity decreases with an increase in shear force. And the third one is rheopectic. Rheopectic substances are the one whose viscosity increases with increase in shear force. And that's exactly what we're going to demonstrate here. So right now you can see we have a glass bowl, we have a bowl of water, that is one bowl of water, and we have 2 packets of cornstarch. So we make sure that the ratio of cornstarch to water is 2:1. Now Shivani is going to add the 2 packets of cornstarch into this glass bowl. And then add the bowl of water that we have, and then mix it. Now while mixing, you're going to see that it's actually a little tough to mix it because this thing on applying pressure converts into a solid and it's difficult to compress it and mix it. Now what you actually saw isn't magic. Shivani is going to pick up another lump of this material from the glass bowl and take it into her hand and compress it as much as she can. Now you can see that it's actually a solid that she has in her hand. But seconds after the pressure is removed, the shear force is removed, the whole mixture converts into a liquid. And we see that there's a decrease in viscosity as solids are more viscous than liquids. So this thing converts from a solid to a liquid, that is the viscosity decreases. Experiment, Shivani is going to take a handful of the mixture of cornstarch and water in her hands, and you can see that it's actually solid, a bit of solid on applying shear force. And then the moment she leaves applying the shear force, it converts into a liquid in the plate. Well, that's no magic, it's pure science. So now, what we want her to do is put her finger in the mixture on the plate, and you can see that on applying shear force, it cracks like a solid. And the moment she stops applying the force, it comes back into its original shape as a liquid. She is going to put her finger through this, and it allows her finger to go inside because it is acting like a liquid, easily allowing anything to drop inside. But when she tries to move her finger, she is unable to move it because it acts like a solid now as her finger is trying to apply shear force. Now this is the basic principle of quicksand itself. The more you try to struggle, the deeper you go inside because it lets you come inside when you apply shear force, but it does not let you come outside of the quicksand because of the conversion into a solid as there is an increase in viscosity. Now there is a stone we have, and that particular stone we are going to try and ram it on this liquidy and solidy thing that we have, and you can see no matter how much she tries to crack it, it does not. But we also know that this thing is actually a liquid which is trying to do all this stuff. So now again we have created a very big crack in it, and again the liquid fills whole thing up. So this is what the experiment is all about. How cornstarch and water mixture acts like quicksand, and there's an increase in viscosity with increase in shear force. Thank you.
Thank you very much for watching our experiment. Hope you all enjoyed.